So the second half of 4.3 will be factoring quadratics just like we did yesterday, but the only difference is that the leading coefficient is not 1. There's going to be a number in front of the squared term. Now this is a topic that is notoriously difficult for students for some reason, and there are a bajillion different ways you can do this. Now, if you're already comfortable with these types of problems, if you already have your own method of doing it, I would suggest you stick with it, right? On the quizzes and tests, I don't really care what method you use as long as you're accurate and quick with it. If you're one of the type of students that, historically, this has always given you some trouble, consider this technique. Now, I want to sort of be upfront and transparent. What I'm about to show is sort of like a parlor trick. It's sort of like a little cheaty shortcut. It's not the proper way to do things, but hey, it works and it might be a little bit easier. It does require you to be masters at yesterday's stuff. So it does require you to be a master at 4.3a. If you are still iffy with factoring quadratics when the leading coefficient is 1, I suggest you practice yesterday's problem some more. So in this video, I'm going to assume we are comfortable with 4.3a. Assuming that's the case, how would we factorize something like 7x squared minus 15x minus 18? That 7 in front of the x squares sort of messes things up for us. So the technique is, well, we're going to get rid of it. So where would be, I guess I'll go ahead and write the steps on the side here. So step 1, you're going to multiply the leading coefficient with the constant. You're going to multiply the first number with the last number. So here's step 1. Right. Multiply. So then that's going to give you x squared minus 15x minus, and if multiplication is not your forte or if the numbers are really big, just whip out a calculator. So we need to do 7 times 18, which is 126. Step 2, you're going to factor like normal. Right. So this is 4.3a stuff. So notice how this new quadratic, it looks like the problems you did yesterday. The numbers are a little bit bigger, but I hope we're fully comfortable with these types of problems. So again, I'm going to assume we are masters at this, so I'm just going to sort of speed through it a little bit. So we have, we know it's going to be parentheses, parentheses, x and x. So I need to break down the 126. So that's 1 and 126, 2 and 63, 3 and 42, 4 doesn't work, 5 doesn't work, 6 and 21, 7 doesn't, well actually 7 does work, 126 divided by 7, that surprises me, 18, what about 8, nope, 9 works, 9 and 14, 10 doesn't, 11 doesn't, 12 doesn't, and 13 doesn't, and we're back to 14 here. So this is the entire list. I want to think subtraction, so which pair subtracts to a 15 here? 15, 15, 15, here we go, 6 and 21. So 6 and 21. It needs to be a negative 15, so that's going to be a positive 6 and negative 21. So that should be the factored form. So again, I did this fairly quickly, but I am assuming that we're good with this type of factoring. Step 3, I'm actually going to color code because it's going to be sort of specific here. So step 3, you want to divide all the numbers by the original leading coefficients. So you notice how in step 1 we multiplied by the front number, we multiplied by 7. So I'm going to take all of these numbers here and divide by 7. In addition, we're going to reduce as much as possible. Right? So here's step 3 is the division step. So you're going to reduce as much as possible. 6 over 7, I can't really reduce that, so it stays as 6 over 7. 21 over 7, I can reduce that to a 3. Now the last step, again, I'm going to color code this. Let's see if this will show. Okay, that's a good color. Step 4. Bring up any denominators in front of the variable. So here's step 4. I look at the numbers, and if there are any denominators left over, you bring it up in front. So notice how the left parentheses, there's a 7 in the denominator. I'm going to bring them up in front. That gives us our final factored form. 7x plus 6 times x minus 3. This is the factored form of our original problem. So these 4 steps will allow you to transform any, quote, hard factoring problem into the easy, simple ones that you're used to. You just have to remember to do step 3 and step 4. That's only the weird trick, the extra kicker in these problems. So that's basically how you factor quadratics without the leading coefficient 1. It's just one out of many different methods. So use whatever method you're comfortable with. But if you've always struggled with these types of problems in the past, this is one little parlor trick that can help you. So the rest of the videos will just be showing more examples, hopefully to get you familiar with the technique and to let you know that once you get good at this, you can be really, really fast. There is only one downside. Since it does involve multiplication, it does make your last number a little bit big sometimes. But hey, if you know your times tables or if you have a calculator with you, it shouldn't be a problem. Let's do a handful more examples because I want to leave you with more than just one. So let's go ahead and factor 5x squared plus 28x minus 12. So, oh no, there's a number in front of the x squared. So the first thing I'm going to do is I take this 5 and multiply it into the last number. So then I treat this like a regular problem that we did yesterday. So the last number is 60, so I'm going to pairwise factor the 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and I think that's it. So that's the entire list. This last symbol makes me think of subtract. So which pair subtracts to a 28? Here we go. So I know it's going to be x and x, 2 and 30. It needs to be a positive 28, and me knowing my pluses and minuses, that's going to be a negative 2 and a positive 30. Here's where the trick comes into play. We originally multiplied by 5, so I have to divide every single number by 5. Reduce as much as possible. I cannot reduce 2/5, so he becomes 2 over 5. I can reduce 30 over 5. That gets me a 6. And any denominator that's left over will go in front. So the final factored form is 5x minus 2 times x plus 6. That is the factored form of our original quadratic. Let's go ahead and do maybe 2 more. And I sort of want to show you where we might get fractions on both sides here. So let me find a good example. Let's see, what would be a good example? Let's give this one a shot here. So, suppose I asked you to factor 9x squares minus 3x's minus 20. So the first thing I would do is take the first number and multiply the last number. So that's x squared minus 3x minus 180. That's a pretty big number, but that's the downside of doing this method. But we got a calculator, so we're not worried. 1 and 180, 2 and 90, 3 and 60, excuse me, 4 and 45, 5 and 36, 6 and 30, 7 doesn't work, 8 doesn't work, 9 and 20, 10 and 18, 11 doesn't work. 12 and 15. What about 13? 13 doesn't work. 14 doesn't work. And we're back to 15. So that's the entire list. So you can see there's pros and cons to this method. The last symbol makes me think of subtract. So which pair subtracts to a 3? That's going to be 12 and 15 here. So that gives me XX, 12, 15. And I need to make it so that becomes a negative 3 in the middle. So that needs to be a positive 12 and a negative 15. Our original leading coefficient was a 9, so I need to divide all the numbers by 9. And then we'll go ahead and reduce them as much as possible. So 12 over 9 I can reduce by 3. I can divide out a 3 from both of those numbers. So if I reduce it, that gives me a 4/3. And then 15 over 9, I can reduce it by 3 as well. So that reduces to 5/3. So you can see in this example, when we reduce, I still have fractions left over, which means any denominator, you move in front of the variable. So your final factored form is 3x plus 4 times 3x minus 5. That is the factored form of our original problem. So there you go. That's how you, factorize when the leading coefficient is not 1. It's a little trick. It's sort of like cheating, but hey, as long as you get the right response and it's the correct factored form, it is useful for us. We can do things like solve equations. Right? If I asked you, find the solutions to 2x squares minus 13x plus 15 equals 0. One way to solve this is by factoring. Notice how there's a number in front of the x squared, so we can go ahead and do our little trick here. But first I'm going to just do some scratch work. So I'm going to do the little trick in the scratch work side. I want to preserve this area for the actual, formal problem. So I want to factorize this guy here. So I'm going to multiply the first number by the last number. So that gives me x squared minus 13x plus 30. That's taking the 2 times the 15 gives me a 30. I'm going to factor this guy as normal. 1 and 30, 2 and 15, 3 and 10, 5 and 6. This last symbol makes me think of add. Which pair adds to a 13? That's going to be 3 and a 10. And it needs to add to a negative 13, so they both need to be negative. The original coefficient was a 2, so I'm going to divide everything by 2 and reduce. 3 over 2 cannot be reduced, so I'm going to bring the 2 up in front. And then 10 over 2 can be reduced to a 5. So that's the factored form. So I'm just going to take this guy here and bring him over to this line. So then we get 2x minus 3, x minus 5 equals 0. And then we can do what we did yesterday, the zero product property, that says if you have a multiplication problem and equals 0, then you can set each piece separately equal to 0 to solve. So solving the left equation, add 3 to both sides, divide out the 2. The right equation, add 5 to both sides, you get x equals 5. So again, use this method if you've always struggled in the past. Maybe it'll help you. If you know of a different method and it works for you and you're always accurate and you're a little bit fast at it, stick with what you know. That is 4.3b.